everybody, this video is going to be pretty quick. So we're just going to do the SN1 mechanism and draw the product for these reagents here. So we just in class learned about the E1 mechanism and E1 products, but E1 reactions go through the same first step, that carbocation formation, same first step as SN1 mechanisms, just the second step is different. So often if you have reagents that can undergo an E1 mechanism, they can also undergo SN1. So this example down here, which we just barely started at the end of class, kind of talking about what the nucleophile and leaving group and alpha and beta carbons are, we'll do the E1 mechanisms together in class in the video. Right now, I'll just do SN1 kind of as a review. So in class, we drew out where the alpha carbon is. That's where I have that lowercase a. That is the carbon bonded to the leaving group. That's the carbon where the reaction happens. Then we have 3 beta carbons that are bonded to the alpha carbon. Beta carbons are relevant for E1, just elimination reactions in general, not for substitution reactions. We don't need to worry about beta hydrogens, but for SN1, so here I'll actually just redraw the starting material here, and this will be our SN1 reaction mechanism, and we'll draw the products. So leaving group is iodine. Alpha carbon is bonded to the leaving group. In SN1 reactions, first step is for the leaving group to leave, and we form the carbocation. So that's what we'll draw as the first step here. So we form iodide, the anion, and we form that carbocation intermediate. Second step for SN1 reactions is for the nucleophile to bond to the leaving group. Nucleophile, we wrote above, is H2O. For SN1, E1 reactions, often the nucleophile is the solvent, which is drawn above or below the arrow. Sometimes we do have a separate nucleophile that's listed as well, but here we don't have anything except for the electrophile molecule with the leaving group, alpha and beta carbons, and then the H2O, which is our nucleophile. So nucleophile bonds to the carbocation. We close the shell of that carbon. The oxygen to hydrogen bonds do not break in that step. They will break in a separate proton transfer step. So oxygen becomes positive since it is now sharing a pair of electrons. Last step will be proton transfer step, and this is just to establish a neutral organic product. So a hydrogen is removed from oxygen. Electrons electrons owned by iodine will now form a bond to the hydrogen. So now in the organic molecule, we have an alcohol group, OH. Now that oxygen is neutral, and then byproduct here is HI. And so this is the complete SN1. We've got step 1, which is carbocation formation, which occurs when the leaving group leaves. Step 2, nucleophile attack. And then step 3 is not a required step in SN1 reactions, but it is often included. This is that acid-base proton transfer reaction step. So sometimes needed in SN1 reactions. So this is the SN1 reaction. The SN1 product is here. And so when we are in class, we will go through the E1 mechanism, showing the different products that we might get from removing different beta hydrogens. So hydrogens bonded to different beta carbons. And so we'll draw all of the possible products. But that'll be it for this video. So just real quick, SN1 mechanism here.